right, are we set up? Do we have video? Excellent. Okay, so the main thing that I'm here to talk about today is Read Write World, which is the spiritual successor in many ways of the Photosynth project, the superset of the Photosynth project, which I have talked about here at Picnic before. And in particular, I'd like to talk about these four things. So first, Photosynth and what's happened with it from the moment we first officially introduced it in 2008 to present. Talking a little bit more generally about spatial media, not only the crowd-contributed kinds of spatial media that Photosynth embodies, but a little bit more generally, what those spatial media are and what the relationships to each other are. And where all of that goes. Is this just about pictures in space? What does that enable? What ecosystem builds up around those? How does that bring us into a future in which we interact with media experiences in the real world from an augmented reality point of view or virtually from a telepresent point of view? Okay, so in 2007, when I came to speak about Photosynth here at Picnic, we hadn't yet released it officially. That was still a tech preview. In August of 2008, we first made Photosynth available for people to use, and since I only have 20 minutes and I have quite a lot to cover, I think I'll not go into details about what the original Photosynth was, but you can always check it out at photosynth.net. When we launched it, it really captured a lot of people's imagination, and there were many, many synths being contributed in those first couple of weeks. There was a huge spike of activity. In the beginning, we started off with a couple of toy photosynths that we had put together ourselves based on pictures from Flickr, and this was similar to what the graduate student Noah Snavely had done as part of his doctoral dissertation. That was really a huge part of the inspiration for Photosynth. So, for example, there was a synth or a 3D reconstruction of the Trevi Fountain in Italy, one of Notre Dame Cathedral in Paris, and these were reconstructions that were formed out of hundreds or thousands of pictures, and they were quite partial because it turns out many people, when they upload photos of things like the Trevi Fountain or Notre Dame Cathedral, they do it from a very stereotyped point of view. That was one of the early findings. We believed in the beginning that perhaps we'd be able to reconstruct very large parts of the Earth by putting together images that were already up there on the web somewhere. We'd kind of have this emergent world build up out of casually contributed media. There's some truth in that, but because people are so predictable in where and how they take their pictures, it turns out that it's quite limited what you can reconstruct from things that people upload casually. On the other hand, within 2 weeks of putting Photosynth up online, we had dozens of synths of the Trevi Fountain, dozens of the Eiffel Tower, or of Chichen Itza, or of Tulum. These screenshots are all from just a couple of weeks after launch, of Angkor Wat, of Pisa, of the Treasury at Petra, of Bryce Canyon, and so on. And these dozens of synths, many of them were richer in terms of their geometric content than anything that we could reconstruct from Flickr and from other public photo sharing sites. I'm sorry if this is all sounding very opaque, if you're not familiar already with how Photosynth worked. Now, just about 6 months ago, we released an app, a Photosynth app for the iPhone, and that's forthcoming on the Windows Phone as well, which isn't exactly like the original Photosynth application that runs on the desktop, but it's primarily geared toward capturing entire environments from one position, from one point of view. And what of course that means is it's a panorama. Panoramas have been around for a very long time, of course. We remember the old QuickTime VR days. But what's fun about panoramas now is that it's possible to let's play here. This is just a bit of a sense of how real-time panorama making looks on the iPhone screen. You're sort of snapping things together in real time, and that's what's. We'll get my face out of out of the way there. What's fun is that the computer vision algorithms for tracking things visually, even on small devices like phones, are now powerful enough. The algorithms are good enough, and the hardware is fast enough that you can actually stitch in real time as you rotate the phone around. So any of you who have iPhones and haven't downloaded the Photosynth app, I would strongly recommend that you do it and try it. It's really quite fun. I'm also very, very proud of the design that the design team put together for this thing. It uses a lot of these same metro principles as the Windows Phone, but it turns out it looks quite beautiful on other devices as well. It's very typographic. And the results, and it got excellent reviews. It was a 5-star app with many thousands of reviews. I love these, I can't believe Microsoft made it sorts of reviews. Those are especially fun. But the problem that the Photosynth app for iPhone solves is fundamentally one of field of view. And this starts to get at the difference between media and places. So this is just one of the very first apps that I captured with a test version of this app while we were still in development with it. And I just did it from my window. And so it's the view from my office. The thing is, if any of you have ever tried to capture the view out a window with your phones or with an ordinary camera, you know that the field of view is very narrow. With our eyes, we see something like an entire half sphere. And it's not only our eyes, of course, it's also our brains. What our eyes are actually seeing is quite limited outside the fovea, but we have this sense of a panoramic expanse, of an entire space. And the cameras on phones are designed for taking pictures like this. So this is a picture, that I took with my iPhone, and the field of view is exceptionally narrow. It's really designed for taking somebody's face at a party or something. It doesn't capture an environment at all. This is, by the way, the globe at the top of the Smith Tower over here, which is where one of our good friends lives. And this is a section of a panorama that I took in the same spot. And you can see that the difference between this and this is the difference between an image and a position and a location in space. So, of course, when you look at it flattened out onto a plane like this, what you're experiencing is something very different from that place. And the kind of distortions that you see are of course, they're familiar from, for anybody who's studied cartography at all. You're trying to take a spherical space and flatten it into a plane. It's exactly the problem of map making on Earth. We're very used to seeing these kind of maps, so this looks quite natural to us until we notice that Greenland is actually only twice the size of Texas, not twice the size of the U.S. This is what that same sort of distortion yields when you take a panorama. This is a panorama that I captured in the Neue Nationalgalerie in Berlin. And all of these straight lines in the ceiling get distorted into curves. Of course, maps have no straight lines in them, so you're not aware of all of these distortions as much. But what these look like, so just to give you a little bit of a sense, this is one of my panos that I captured in Reykjavik at midnight a couple of months ago. And so you rotate the phone around to capture the thing, and you end up with this immersive experience. This is what happens, of course, if you don't flatten it out into an image, but you allow it to be experienced as an environment. And so this is now no longer a piece of media in the usual sense. It doesn't express a particular point of view in the orientation sense, right? It's every point of view from this location at this time. So you've nulled out one of the dimensions of photographic expression. Instead, you have a representation of a place at a time. And it's the nice thing about this app is that it really, if you get your feet out of the way, you can really get the entire sphere, all the way from floor to ceiling, 360, and so on. So it's a beautiful app. It's halfway, I think, to where we want to go, in the sense that what you really want, and what the original Photosynth, I think, was never quite able to deliver, is to be able to capture entire extended environments, looking at every direction, and being able to move as well. So we have the looking in every direction now being stitched in real time on the phone. The next step, of course, is to extend those environments through space as well, and to capture the entire essence of a place, and crowdsource all of that, of course. So the crowdsourcing went really nicely. This was from the launch of the Photosynth app, the number of panoramas that were being contributed to the website, and the geospatial distribution of those of the panos that were being made public. This is again just the first. I think this is just the first couple of days of the app. We were very, very happy. Now let's think for a moment about not just this stuff that people shoot, but also about all of the content that Microsoft, through its mapping legacy, brings to the table in terms of geospatial media. And a lot of that is in the form of aerial imagery. Aerial imagery is one of the areas where Microsoft has really done an excellent job of doing this. It's not satellite, it's actually cameras that are mounted on the bottoms of planes. They're these massive, very, very high-resolution cameras that can handle enormous images and photograph multiple times a second as planes fly. And of course, we've also been doing some street-side imagery. This particular project, the Global Ortho project, which we announced this past year, is, as far as I know, the largest aerial mapping project ever undertaken, and we did it at a small fraction of the cost of similar sorts of captures that the U.S. government has done. So it's 30-centimeter capture blanketing all of the U.S. and Europe over the next couple of years, and so this is the kind of resolutions that we're talking about. Of course, we're familiar with imagery at some of these sorts of resolutions in particular places, in urban environments, but we're not talking about that everywhere, that blanketing the entire environment. And if you take now all of that imagery and you apply the photosynth type computer vision technology to the images, you can also reconstruct the three-dimensional surface of the Earth with tremendous precision. So what we're looking at here is a digital surface model where the grays represent heights above ground of one particular patch of Vienna, sampled at 75-centimeter resolution. And so none of this is from radar or LiDAR or anything like that. It's just reconstructed purely from the images. And this is in the city center, so the buildings are showing up as white blocks on a black background. This is zooming in at 75-centimeter resolution. And that's the imagery overlaid with the height field. Rugged terrain, a farm area. So this is just a beautiful surface model everywhere that this stuff is being flown. And I hope that this is a project, now that the technology is in place, that can really expand into other places. Hopefully we can do Africa as well, for example, where we've been talking with some people about that. So once you have the digital surface model, you can do certain sorts of processing, like figure out what's water, what's vegetation, what's hard surfaces. You can generate a digital terrain model, which is sort of a bare earth model underneath the buildings out of that. You can classify, you can get building footprints out, and you can do 3D reconstruction of the buildings automatically without any manual interventions at all, so completely automated pipelines. It's also interesting to note that not all of the photos, in the beginning we thought that photosynth was going to be purely about human scale acquisition, about interiors, about streets, about places that people walk. But one of the interesting findings from the first few weeks even of photosynth was that a great many synths, a great many user-contributed captures were happening from the air. And the number of ways that people did this from the air is kind of staggering. There are unmanned kites, there are small planes, there are panoramas from skyscrapers, there are strange gas balloons with cameras mounted on them, cable cars, all sorts of things. And some of these really are at resolutions and at qualities that are higher than we can even capture ourselves with the planes, much higher in some cases. This is one early example. This is, again, very, very early in the project, back when Bing Maps was still live maps. This is the kind of crappy map that we had at the time of the Primosten Peninsula in Croatia. And that is the point cloud of a single synth that one user contributed, which shows entire little island that wasn't even on the map. Lucky Bobeda. And these are some samples of his imagery on top of the point cloud. And he was photographing at resolutions that I don't think we're even allowed to. If you look at what is have I just now succeeded in freezing my computer? No. If you look at what we can do with those sorts of data from user-contributed captures from the air, when you process them using the same sorts of algorithms that we use for our own aerial imagery, you can get these sorts of extraordinary reconstructions. This is Kelvin Grove Museum in Scotland. It's just point cloud. So this is not even a real 3D model. It's just a cloud of points. But you can see the resolution is just incredible, even before you've processed this into a real building model of any sort. Or let's see, this one is even. There's one that's even better that I've got on the desktop here. This is the Empire State Building, and this is, I think, from a helicopter. So somebody just took, and it's rippling in the wind as well. This is the big quake that's going to hit. But this is just points, and it's from a single overflight in a loop around the Empire State Building in a helicopter, I think, and it's just a cloud of points. It's much more detailed than our own models. So all of this begs the question: what happens if we take all of these things and we start to put them together? We start to weave all of these things together that are contributed by us, that are contributed by users, that are mined from elsewhere in on the web, especially things that are media that are Creative Commons and that are designed to be remixed. One of the things that we've always done from the beginning with Photosynth is to try to encourage Creative Commons contributions to Photosynth, so that all of those media that are contributed to that collective version of reality can be remixed and made into new things. What happens if you do that? What happens if you try and form all of those connections? We have a lot of different sorts of media already that we've been playing with in one form or another, and we have a lot of different ways of rendering those that we've experimented with over the years. You know, so far we haven't done a great job of surfacing all of that stuff in all these different rendering platforms. One of the goals of this new project called Read Write World is to really surface all of that stuff in a uniform and read-write sort of way that allows everybody to both consume and to contribute. You know, a lot of this has to do with the fact that all of these different kinds of media, they all have a lot of things in common. They're all almost all imagery of one form or another. They're almost all multi-resolution. In some cases, you can think about them as being cube maps or environments. In some cases, flat images. In some cases, they have what is called proxy geometry, meaning geometry that you can project the imagery onto, in some cases not. But we're talking about converging all of those things together. That's what the Read Write World project is all about. We're now at the same stage with the Read Write World project as we were with Photosynth when I first came to talk about this at Picnic, so not quite at public release point yet, but sort of gearing up for it. And I can give you a little bit of a demo to give you a sense of what we mean when we talk about this convergence of media of different sorts. Let's see. So this is just a little sort of test viewer. Let's see, maybe I should actually reload this thing because I think the computer was asleep when we first loaded it. So this is a test viewer of media, and actually I'm not seeing what I want to see. Ah, there we go. So we just took a single section of our street slide data product, which is the panoramic imagery that we've captured as we go down a street, turned into a planar panorama that represents one particular face of a block. This is a nice way of navigating blocks, especially on phones when you want to not use very much bandwidth. You want to be able to quickly explore. When this is important to do, digression, but because GPS in cities tends to only be accurate to plus or minus 50 meters or so, you really want to be able to swipe quickly and explore one side of a block or another when you're doing this kind of work. And so here we're taking two pieces of media. One of them is the planar map, and the other one is this street slide thing. And they have a relationship to each other, which is, in this case, just a coordinate relationship, a graph relationship. And so now we're in this guy, and here we have a coffee shop, and so it's identified semantically. Of course, we have semantic identification for many, many businesses. That's where local search comes from. And it turns out that in here, we have panoramas in the interior of that business that have been captured with the Photosynth app. Whenever you can relate using computer vision those panoramas to any panoramas that we took, that we know the precise relationships between, then you can generate transition videos that create continuous transitions among those. So this is now, of course, not Microsoft's. This is David's. So it's David via Photosynth. So it's a person's media. It's not our media in any sense. And this is his too in the rear of the cafe. And again, because the rear of the cafe and the front relate to each other using in the Photosynth sense, you can make continuous transitions among those. Think about this like a graph, where anytime you have an edge of the graph where the media can connect visually, you can generate those sorts of transitions. And in fact, here in the front of the cafe, we had some artwork. There was a close-up of this piece of artwork, and this particular close-up is its copyright is Lauren Aldrich, who is the creator of this particular artwork. So this is a planar image by Lauren. This is a panorama by David out here, and this is block view by Microsoft, and this is a map also by Microsoft, all related to each other spatially. And all of those renderings that we've just shown, so this particular prototype is actually built in Silverlight, but the principle behind all of this stuff is that it's all very CSS 3D friendly. And so these are fundamentally web technologies. We don't need non-web technologies to render in any of the ways that I've just demonstrated. So by starting to build up that graph and interconnect all of those kinds of media, what we're hoping to do is to form something that's not a closed environment the way Virtual Earth is, or the way Google Earth is, or whatever, but that is a completely open environment in the same way that the web is, that we've indexed spatially, and that we expose all of those transitions and all of those mechanisms for interaction with in such a way that they can be fully mashed up. When you use technologies like CSS3 to render, of course, that means that you're enabling mashup from the very get-go. So that's the ambition of Read Write World. It's a fairly ambitious project. And the last thing that I guess I'll say, I have more slides, but I don't think we have time to go into it all. This is a very geeky one, whatever. One thought that I'll end with is that a lot of these technologies are building up toward a vision that isn't just about a static world in which all these media are interconnected, interrelated, and read-write and real-time, but in which you can actually think about yourself in that world in an augmented sense. Because what the Photosynth app on the iPhone shows is the way we're now able to do vision-based tracking of the environment in real time as you rotate the camera around. So we're able to take the images that you're looking at through the viewfinder of the camera and relate them in real time to each other as you move the camera at 30 frames a second. Once you're able to track like that, and you're also able to connect your initial keyframes with some version of the world that's already online, you now have all of the foundations that you need for enabling augmented reality, real augmented reality, not just this sort of magnetometer and accelerometer type nonsense that has things floating on top of the viewfinder without any real relationship to the imagery that you're looking at. And so that's the platform that we're talking about. It's the mirror world in an open context, in a way that can be read from, written to openly, where the rights are just as open as the connections, and where the connection can be either established through a telepresence or through an immersive augmented presence. All right, so I'll stop there. Thank you all so much.
Thank you, Blaise. Thanks, Blaise.